Hi there and welcome to our penultimate lesson in our B6 topic on Beyond the Microscope, and today we're going to be looking at enzymes, which are biological catalysts. Anyway, we'll be looking at how they're used, where they're used and what processes they might do. We'll also look at a couple of reactions that they are involved in. Anyway, I hope you enjoy it and I'll see you at the end. Okay, so our objectives for our lesson on enzymes are: by the end of this lesson, you should understand what the uses of enzymes in different industries such as food, cleaning and in medicine. Enzymes are biological catalysts that can be found in most living cells. They can speed up and often start reactions that are useful in everyday things, such as food preparation, medical and in some industrial and home processes. Here is an example of a few. Cheese making uses enzymes, as does juice extraction to alter and or improve food flavouring. Medical products such as glucose test strips, and also biological washing powders which contain enzymes which will remove most biological stains. A biological washing powder is able to remove stains from food which include food, blood or grass, and that's because these are insoluble, so they're difficult to remove away. However, you can add an enzyme that will help remove them and put them or convert them into more soluble products. There are three types of enzyme that are found in biological washing powders. These include amylase, lipase and protease. Now, amylase is used to break down carbohydrates, which includes starch and cellulose that is found in grass. And what it will make is it will make the soluble products of sugars such as glucose. Now, lipase, as in lipids, will break down fats, and that will turn those into fatty acids and glycerol. And then protease will break down proteins into their constituents of amino acids. Now, in order for enzymes to work, they need to be at a temperature of 30 to 40 degrees C. Anything higher can cause the denaturing. Anything lower and you have a slow rate of reaction. The water also needs to have a pH of about 7. If it's too acidic or too alkaline, then the enzymes won't work so well, and that's because the active site changes its shape and can no longer function, so therefore we're not getting the effective breaking down of these insoluble molecules. Food is normally sweetened by a common sugar known as sucrose. Now, sucrose comes from cane sugar and it is known as a disaccharide. Now, obviously we know the di means two and the saccharide means sugars, and that's because sucrose is made up of two constituent sugar molecules. Here we can actually see sucrose and the two different sugar molecules. Now, it's broken down by an enzyme known as sucrase, which is sometimes known as an invertase. Now, it's broken down because the products are actually sweeter than the reactants. So the two products are fructose and glucose. Now, fructose is quite often found in fruits, and glucose we know is quite a common sugar. Now, these two sugars are then used quite often to sweeten desserts and sweets. The sweetening occurs without having to add any extra sugar, and it's often used in low-calorie food and drink. Some adults are lactose intolerant, which means they cannot break down the sugar lactose, and this is purely because they do not produce the enzyme that breaks down lactose. Now, that enzyme is known as lactase. Now you might be able to see here a bit of a pattern that the sugar ends in O's and the enzyme that breaks it down ends in A's. Now because they don't contain the enzyme lactase, the sugar lactose is able to make its way into the large intestine. Now in the large intestine there is bacteria that are able to ferment the sugar, and that ends up resulting in a large amount of diarrhea and gas production. Now enzymes can be used to make lactose-free milk. So they use enzymes to turn lactose into the smaller sugars of glucose and galactose. Now it's not just humans that are lactose intolerant. Adult cats are also lactose intolerant, and that's why cat food manufacturers produce lactose-free milk. The use of enzymes, or extracting the enzymes and purifying them, is very expensive. It's very useful to be able to reuse and reclaim the enzymes at the end of a reaction. Now the best way to do this and not contaminate the final product is to use something called an immobilised enzyme. Now an immobilised enzyme means it is not moving, so it is attached to something that is stationary. Now in most cases this can be reagent sticks or alginate jelly balls. This means that they can be easily removed from the reaction mixture. Now enzymes immobilised in gel beads by mixing the enzyme with alginate and then dropping them into a mixture of calcium chloride solution. This makes them more useful as they can be used in a continuous process. Immobilised enzymes are put into a reactor, the reactants are added at one end and then continuously siphoned off at another end. Now people that are diabetic have to regularly test their urine and blood to check they have the right amount of insulin. Now they do this with something called a Benedict's test. And what the Benedict's test does is it tests for sugar. However, it requires a large sample of blood or urine. The sample is heated with Benedict's reagent. If the reagent is blue, it turns a brick red if the sugar is present. Now attaching enzymes to the reagent sticks means that you can actually test the urine or the blood to find out whether the sugar levels are high or low, and that can give you an indication of how much insulin you might need to inject. And you can see from the diagram here you've got the immobilised enzyme on the reagent stick here, and then you can test the amount of glucose at the end. Okay, so that concludes our penultimate lesson on enzymes, where we have looked at how biological washing powders use enzymes and what the enzymes are in biological washing powder. We've looked at how we can improve the sweetening of food, especially in low-calorie food, by using sucrase to break down sucrose. We've also looked at how milk manufacturers can make lactose-free milk, and we've also looked at immobilised enzymes and how they are made. Anyway, I hope you enjoyed the lesson, and I will see you next time. Bye-bye.